Before humans ever told stories, before jungles echoed with birdsong, there was a world so hot, so dense, and so unfamiliar that something impossible ruled it. Not a dinosaur, not a dragon, but a shadow that moved without sound, longer than a school bus, heavier than a truck, and built entirely of muscle. At first, all we found were fragments, broken bones buried deep in stone. And yet even those fragments whispered a warning. Whatever lived here should not have existed. To understand Titanoboa, we have to step into its world. 60 million years ago, the Earth was recovering from a mass extinction. The dinosaurs were gone. The rules of life were being rewritten. What replaced them was a planet trapped in heat. The air was thicker, the forests were darker, and the temperature rarely dropped below what today would feel unbearable. This wasn't just warm, it was extreme. And here's the strange part. Snakes are cold-blooded. They depend entirely on their environment to survive. Which raises the first mystery. How did a snake grow to monstrous proportions when cold-blooded animals are supposed to have limits? Scientists believe the answer lies in the heat itself. In a world this hot, a snake's body could grow larger without shutting down. But that explanation only opens another door. If Titanoboa needed such extreme conditions, what happens when those conditions disappear? Titanoboa wasn't fast. It didn't chase. It waited. Its body was thick, absurdly thick, wide enough to wrap around prey and never let go. Modern boas kill by squeezing, slowly cutting off blood flow to the brain. Now imagine that pressure multiplied several times over. One coil, one tightening, silence. What's unsettling is what Titanoboa hunted, giant crocodile-like creatures, animals that today would sit at the top of the food chain. This flips our expectations. Why was a snake, not a predator with claws or teeth, dominant in this ecosystem? The answer may be efficiency. Titanoboa didn't waste energy. It didn't roar or charge. It was a living ambush. And yet, we still don't know how often it fed or how long it could go without eating. Some scientists suspect weeks, others think months. What we've discovered only deepens the mystery. At nearly 50 feet long, Titanoboa pushes against the edge of biology itself. As animals grow larger, their bodies struggle under their own weight. Bones must thicken, muscles must work harder, movement becomes costly. But Titanoboa had no legs to fail it. Its entire body was a single flowing structure, a design that may have allowed it to grow beyond what land animals could tolerate. Still, there's a problem: water. Many scientists believe Titanoboa spent much of its life submerged, using rivers as both cover and support. This raises a larger question. Was Titanoboa more aquatic than we realize? And if so, are we underestimating how many giant predators once hid beneath ancient waters? Titanoboa didn't last. As the planet slowly cooled, the world it depended on collapsed. Temperatures dropped, forests changed, and the giant snake vanished. This suggests something unsettling. Titanoboa may not have been an anomaly, but a warning, a reminder that evolution doesn't aim for balance. It pushes until the environment says stop. Which leads to an uncomfortable thought. If Earth's climate shifts again, what kinds of creatures could emerge next? Scientists still don't know where the true upper limit lies, or if Titanoboa was just the largest survivor we happened to find. Titanoboa is gone, its rivers dried, its world cooled, but the stone still remembers. Every fossil is a message from a planet that once played by different rules. And the deeper we dig, the more we realize how temporary our version of Earth really is. There were giants before us. There may be giants after us. And somewhere beneath our feet, the past is still waiting, patiently, like a coiled shadow in the dark.